Hello, this is Mrs. Brown, and today we're going to be talking about the Pythagorean Theorem and specifically Pythagorean triples. Now, this is going to be very brief on the Pythagorean Theorem because basically it's just kind of introducing Pythagorean triples because they're really useful when you're doing distance formula. Because if you notice, you have one distance of 3, one side, and then 4. That diagonal is going to be a whole number, and you don't actually have to use the distance formula if you know your Pythagorean triples. So it makes it easier to solve some problems. All right, so basically Pythagorean theorem has to do with right triangles. That's the right angle right there. And the side opposite the right angle we call the hypotenuse, and it's usually referred to as C. Its square equals the sum of the squares of the other two sides, the two legs. So a squared plus b squared equals c squared. So when we're doing a distance formula, you imagine that we're on a coordinate grid, and you could go and form a right triangle between any 2 points. And if this happened to be a squared and this is b squared equals c squared, to find that distance instead of necessarily doing the distance formula. It's whatever's going to be easier. Okay. This actually, the distance formula is derived from the Pythagorean theorem. So they use this to create it, basically. All right. So what are Pythagorean triples? Well, all 3 sides of a right triangle are whole numbers, and it only happens some of the time. And these are 4 of the most common ones, and actually all of these and their multiples. So if I have a triangle that's a 3, 4, 5, that's going to be all whole numbers. If I see 3 and 4, I know that's going to be 5. Or if I double this, so it's 6, and I double this, so it's 8, then I double 5, which would be 10, and I could find my missing number. So any one of these 4 or any multiples of those, so if I times each of those numbers there by 2, or if I times each of them by, say, 7, 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35. That would be another Pythagorean triple. The reason this is useful is a lot of problems in geometry, especially when they want a whole number, will use these relationships. And if you have them memorized, it saves a lot of time and effort in terms of not having to do the whole distributive property out. But again, if I just check this one, 6 squared plus 8 squared, okay, 6 squared is 36, plus 8 squared is 64, and that's 100, and the square root of 100 would be, in fact, 10. And so, again, that's what we're talking about when I'm talking about the Pythagorean theorem. So if I take the square root of both sides, I get a side of 10. Okay, but for now, we'll come back to this in a later chapter. Working on memorizing these, or at least having them written down so they're easy use, will save you a lot of calculations if you start to recognize them. But a lot of problems will use these number relationships that we'll run into this year. Okay, I hope this helps, and have a great day.